Hello, everyone. I'll be talking about Silex, from micro to full stack. The goal of this talk is to explain the Silex micro framework and how you can evolve it to use Silex for complex applications. So if you don't know me, I'm not only a celebrity from Jeopardy, but I'm also a consultant and trainer at SymfonyLive, where I help teams develop Symfony 2 apps and work with Silex and Symfony. So I've been in the community for quite a while. I used to work at Yahoo, built a couple Yahoo properties with Symfony 1, and now I do consulting and training. So if I can ever help, feel free to find me on IRC. I'm happy to help anyone. So how many of you have used Silex by a show of hands? All of you? Excellent. All right, so you might know Sinatra or maybe Express or Flask. Pretty much all of these are inspired from Sinatra, which is a Ruby-based micro framework. Silex's goal is really to be just very simple. So it's based on Symfony 2 components. It's really just a cohesive set of Symfony 2 components on a lightweight framework. It's easily installed with Composer, so I'm sure all of you are aware of Composer and how easy it is to get started. And of course, it's created by the incredible Fabien Potentier, and it's licensed under the MIT license. So if you want to follow along, feel free to go to silex.sensiolabs.org, and all this code comes from that site, as well as I've set up a GitHub repository. So a bit about the philosophy. Symfony 2 is really a full-stack framework, and the goal is to be the opposite. In Symfony 2, all the features are there by default, and you turn features off if you don't need them. In Silex, nothing is there by default, and you add providers as you need to implement features. So a lot of things that you won't find in Silex are like a command line tool, or things that aren't PHP-ish, like annotations. There's no annotation support in Silex. And anything that requires editing the core code, the application class. So why use Silex? I think for a lot of applications, a full-stack framework is overkill. Really, for simple apps, you just need to be able to map a route to a controller class, or a controller function in this case. So I think Silex is great for simple apps. It's really concise, extensible, and testable, and we'll dive into each of those. So again, if you want to follow all the examples, I have a backbone to-do list, a hello world example, and like a kitchen sink example. Feel free to clone the repository at github.com/Dustin Whittle /Silex/SymfonyLive 2012. Okay, to get started, first you need Composer. So it's very easy to install, just curl-s. getcomposer.org/installer, pipe to PHP. Once you do that, all you really need to add is Silex as a dependency in your composer.json. So here, Silex requires PHP 5.3.3. And if you have PHP 5.4, Silex takes advantage of it, so it has support for traits in some cases. But the minimum requirement is going to be PHP 5.3. So once you've set up a composer.json file, is literally the only line that's important is the line that says Silex/Silex 1.0. And then you can run PHP composer.var install, and you're all set. That's all it's required to install. So simple app structure, if you're using Composer, is you'll have a vendor directory for your Silex dependencies, as well as any Symfony components that you want to add, as well as you'll have a web directory. So Silex is built for a single file, right? In Symfony, you have a front controller, which routes all the requests to the framework. And Silex, your front controller is your entire application. So here we have a web index.php. So what does this look like? In its simplest form, we do the traditional hello world example. And we have a require once, just to include the autoloader from Composer. And then we're going to create a new app instance. So here we have app equals new Silex/application. Then this is just bootstraps the app, but it really does nothing until you add functionality. So here we just want to map a route, so /hello/name, to a function that returns /hello and then escapes the name. Until you call app run, nothing happens. All you're doing here is mapping the controller, the route to the controller. When you call app run, that's when all the magic happens. That's why you can put this in a single file and point a web server at that file, and it'll just work. So what does this look like? /hello/SymfonyLive. Hello, SymfonyLive. And you can use PHP's built-in developer server just to bootstrap. So you don't even need Apache or Nginx to set up just to get started developing. You can literally clone this project. You have this directory structure and run php-s on port 80, pointing it at the web directory, and you're ready to go. Usually you want something a bit more complex. Maybe not as complex as Symfony 2, but you want some structure to your application. You want to use Twig for templates, or you want to have a different files for your controllers. Fabian has created an excellent skeleton that gives you some basic structure. And again, you can use Composer to bootstrap your application very easily. So here we have composer.far, create-project, fabpot, Silex skeleton. And what this will give you is a very simple app structure with configuration for a developer environment and a production environment. And really all this does is register the exception handler from Symfony. So if you're used to Symfony's pretty exceptions and useful error messaging, you can get that in Silex very easily. It also gives you app console, an application class just to bootstrap your application, and a controllers class to just have a file where you can register your controllers. Furthermore, it adds templates, so you have integrated Twig support, and you have a 404 page and a 500 page by default, as well as, since you've now added the Twig dependency, you can have template inheritance. So I can have a layout.html and an index.html that extends that layout. And then we have front controllers, one for production, one for development. So if we take a look at this really quickly, let's skip right to code. Can anybody read these? Yeah? Is that good? All right, so this is our traditional Hello World example. But what if I want to move this controller into a separate file? How do we do this? This is the Hello World example. If we go to the skeleton, you can take a look at the structure. So here we have a config with the dev.php. And all this really does is set the debug mode to true, app debug to true, and this enables the exception handling. So if you throw a message, it will actually give you a pretty exception instead of serving the 500 page. And then you can register any providers, which we're going to dive into in just a second. In this case, I just want to add support for logging, and I just want to register the monolog service provider. We have our production config, which is empty, because really the only thing we care about for dev is exception handling. And then we have our controllers. So in this case, all we're going to do is create a controllers class and migrate our controllers into this file. So we have, in this case, just a home page that returns HTML view, index.html, and binds to a home page route. And then we're going to add an error handler in case anything goes wrong, just to throw an error page. So this is where the error handling happens for Silex right now. And then your front controller is very simple. All it does is you move your controllers to a separate file. So let's include your production configuration, and let's include your controllers, and then call app run. And if you point this to your browser, you'll get something that looks like this. Very simple, just returns an HTML page. Welcome to your new Silex app. But usually you want to do something a bit more complex. So you want to add features. You want to add useful things like maybe doctrines deval so you can have access to your database, or you want to add templating and views, or just log files. So with the skeleton, again, you have localhost. If you just go to localhost, you get to index.html page, which is just a Twig template. If you go to a 404 page, now we have an actual router, so it can detect whether the route is found or not. If you go to a route that doesn't exist, you go to a 404 page. And if you have an exception, you get Symfony's pretty exception messages, just like you do in Symfony. What you'll notice is that everything you do in Symfony, a lot of it you can do in Silex. It's just that you have to add the functionality manually instead of it already being there. So all of the components that you're already familiar with, the logging implementation, the HTTP foundation with request response, all of this works the same way in Silex. So how do you add features? So in Silex, you have service providers. In Symfony 2, you have a community of bundles. Bundles are very similar to providers as they just expose functionality to an application. Service providers are lightweight, and their goal is really to just expose a service, but you could also expose controllers and views if you wanted. So Pimple is a simple dependency injection container. I won't dive into it too much, but you'll notice in all the examples we have an app class. So if we go back, app itself is the container, because we can just inject new services into this container, like Twig or Monolog. By default, Silex comes with a list of core service providers for URL generation, for session management, if you want to use the form and validation system, as well as if you wanted to add a security system or just translations. If you've ever used the HTTP cache system, you could easily plug it in and have support for ESI as well. And then, of course, Twig, Doctor, and Monolog, and SwiftMailer. So how do you add URL generation? By default, there's already a router, which is I can take a URL and I can figure out which controller to map it to. But what if I want to do the reverse? And I want to say, okay, for this controller, give me the URL. Well, we need to add that additional functionality. Again, Silex is dead simple, so you need to add new features. In this case, we're just going to use the URL generator service provider, and we're going to register this with the container. So we'll call app register, pass it the service provider, and now we can use this functionality. So if I want to generate a URL, one, I register the URL when I map the controller. So in this case, you have app get, the URL, a function that is your controller, and then the bind method. The bind method is really what gives this route a name. So I'm saying this /URL is bound to the homepage name. Now, if I ever want to generate the URL, I can simply call app URL generator and generate the name of the route, just like you can in Symfony. All these methods, all the components underneath, are all Symfony 2. So all the methods map one-to-one. Now, what if you want to add sessions? Sessions are really common and a lot of times are needed, even in lightweight applications. It's extremely easy. Most of these examples are one line, right? I call app register, I register the service provider, and now I can leverage it in my application. So in this case, I call app register session service provider, and now I can call the app session service and call set a user, and get a user. The same for Twig. Integrating Twig is extremely easy. Again, app register, the Twig service provider, and in this case, you need to pass a path to where to look for your templates. So we pass in that attribute Twig path and just give it a relative path to templates. And now when I want to use Twig in my controllers, I can simply do return app Twig render, just like you can call a render method in a Symfony 2 controller. Translations require a bit more configuration, but the same principles apply. If you want to add translation support to your project, even if it's lightweight, you can simply call app register translation service provider, and now you register the Symfony 2 translator. If I want to use it, first I need to define a dictionary. So in this case, I'll define app translator domains, and I will pass in a list of messages. And here we just have two messages for two translations, hello and goodbye in English and French, as well as they're parameterized, so I can pass in a name. And if I want to translate this, just like in Symfony 2, I have app translator with a trans method that passes in the message and a list of arguments. Okay, everybody loves Symfony 2 forms. And they're very easy to implement in Silex, just like the validation component, although it requires a bit more configuration. In this case, we're going to app register, and we're just going to register the form service provider, just like all of the other ones. And we're going to create a new form. So just like you have a form factory and a form builder in Symfony 2, here you have a form factory service that allows you to create a form builder. And from the form builder, you can simply add form fields. In this case, we have three choices: name, email, and gender. And then, just like Symfony 2, if the request method is a post, we want to bind the request to the form. If the form is valid, I want to get some data. I want to do something like update the database or fetch a web service. And then I want to redirect. Otherwise, I just want to return the form with the form view. Now, right now, this has no validation, but we could really easily add validation by including the validation service provider. In this case, we're going to take the same form, except for add some constraints for each field. So we're going to register the validator service provider as well as the translation service provider, as a lot of times you need to translate your validation messages. So here we create the same form factory, create a form builder, add fields called name of type text, except for this time we're going to specify some validation constraints. So the same as in Symfony 2, we have assert not blank and assert min length of 5. For name, for email, we're just going to assert that it's a valid email address. And for gender, we just want to assert that the choice was within our set. So we have 1 for male, 2 for female. And we just define the constraint. It's a choice constraint with this array of 1 or 2. And now we can validate our form just like you would in Symfony 2. It should be pretty straightforward. The same Twig helpers that you have are also registered if you're using the Twig component. There's also the bridges, which you didn't see is me having to go to Composer and manually add these dependencies. This is because I started with the example from Fabian. The Silex skeleton already has all this configuration done for you, which is why it makes sense to just bootstrap your project from here. because the twig is set up, the bridge is set up, and the views they just work out of the box. Which means I can do form action, and I can call form widget on the form itself, and it just prints the form, and I can submit. How about HTTP caching? HTTP caching is very powerful, especially for lightweight applications. Most of the time you don't need to generate the page every request. It's something that you could cache for some short lifetime. It's extremely easy to do if you implement the HTTP cache service provider. In this case, we're just going to pass it a path to where to cache the files. So we set the HTTP cacher. And from there, as long as we return a response objects with the cache control headers, the HTTP caching system will automatically deal with not making the request twice. And just like Symfony 2, you can use shared max age of 5 or max age depending on your constraints. You could also use e-tags, etc. Now, I'm going to show Doctrine, but I want to be really clear about, I'm not going to show Doctrine ORM because an ORM is usually overkill. If you need an ORM, you should probably use Symfony 2. But a lot of times you just need lightweight database access, and the Doctrine deval does a very good job of this. And really all it does is expose a PDO object that you can use. So here we just register the Doctrine service provider. We give it some options. In this case, we're just going to use the PDO SQLite, and we're going to pass in a path to a SQLite database. Now if I want to run a query, I can just call appdb fetch associated. And appdb is really just a PDO instance. Okay. How about integrating a simple JSON API? I have database access now. I have a way to route URLs to controllers. This is really all you need for a simple API most of the time. This is where I think Silex's sweet spot. I think this is ideal. If you just need a really lightweight backend API, use Silex because all you really usually need is a simple URL to controller and a way to encode JSON and access your database. In this case, we now have Doctrine implemented, so for a simple to-do git, we could map the /to-do/id, and then call appdb, select star from to-do, where ID equals some value that was passed into the request. If I don't find the to-do, I want to abort the request with a 404 error. Otherwise, I just want to return the app to-do with the JSON encoded. One thing you'll notice is just like in Symfony 2, if you look at the function, we require a request parameter called ID, and if you look at the function, you can pass in ID. So you can either pass in ID, you can pass in the app context itself, or you can pass in the entire request object, depending on how you specify it, and Silex will automatically adapt. So if you just want to pass in a request and access all of your parameters just from the request object, you can easily do so. But if you have a required parameter, you can always just pass it directly into the function. So again, monologue is usually really straightforward. In this case, we just want to register the monologue service provider, specify the monologue log file. In this case, just the log directory, app.log, and then we can access our logger. So we just access the app context, which is monologue. This is our container, and it has a method called add_debug or add_error, etc. Everybody hates SwiftMailer, but we use it anyways. So you call app register, SwiftMailer service provider, and then you can easily create a Swift message, use the app mailer, and simply send the SwiftMailer message. All of these are really easy. Again, the idea is you have exposed simple functionality with service providers. You have an app instance, which is the Silex app itself. You register new service providers to expose that functionality, and then you can just access it through the app's container, which is app mailer, app monologue, appdb, etc. Just like Symfony 2, if you want to return response objects directly or twig templates, it's done automatically. In this case, I just returned a new response with a 201 created tag. I think security is overkill for Silex applications. Usually, if you need security, you should probably just use Symfony 2. But we do support it with a security service provider. The security system in Symfony is quite complex, just like the forms, but I wanted to show a quick example just to show how you could have an admin path that requires an admin permission and check for a registered user. In this case, it's a little bit more complicated because we need to create a security firewall. And just like Symfony 2, we register a firewall, in this case /admin, and everything that matches /admin. If you're not authenticated with the role admin, we will redirect you to the login path, and we expect the credential role admin. Once you're logged in, you can access the user's token, which could be the user object or it could be an OAuth token or whatever you need, an app security get token. Okay, so what is a full stack framework? I think Symfony 2 is a full stack. It's a traditional full stack framework where it has support for databases, support for caching systems, support for logging, email, et cetera, et cetera. All this is exposed through bundles. But even more so, it provides default conventions. There's the right way to do it. There's a default structure. What Silex, you define your structure. There's also support for configuration, XML, YAML, INI, et cetera. And again, in Symfony 2, you remove features. In Silex, you add them. So you start from nothing with Silex, and in Symfony 2, you have everything by default. How do you evolve Silex to a full stack application? You have to add your own structure. So where do I put my controllers? Where do I put my templates, etc.? So let's take a look at that. How do you expose new functionality? We're going to expose new functionality with service providers, and this really comes down to moving controllers out of a single file, possibly using Twig for templates, and adding any support for third-party systems, like if you need to access Memcache or you want to use Doctrine or any other service that you need, possibly Facebook or whatever makes sense for your application. Okay, when you start with the Silex skeleton, here's your list of dependencies. You start with Silex, you add support for Twig, we add support for the monologger, and then we add a bunch of the Symfony components, like the form, the validation. If I want to use testing, I could use the CSS selector and the browser kit. But otherwise, we just need some basic dependencies. If it's supported in Composer or in packages.org, you can easily add it in Composer and just expose it to your Silex application. One of the things that you can do, just like in Symfony, you can create custom commands. Like in the first slide, I said something Silex will never do by default is have its own command line utility, but that doesn't mean you can't use Symfony's command line utility and create your own console. So here we just take the console component, create a very simple Silex application, and we just simply register my command. It has a description, has an input interface and an output interface, and again, just like Silex, you just have some simple controller or some simple console task. So you can take any component from Symfony 2 and easily glue it into a Silex project and start using it, whether it's the console command or whether it's the browser kit for testing. It's extremely easy. You add it to composer.json, register the service provider, and you're ready to go. Now, Silex only has certain providers by default, and it's really pretty limited because the goal, again, for Silex is to be extremely lightweight. But that doesn't mean there's not a huge community, just like there is with the bundle community in Symfony 2. So here we have Silex extensions. By default, you probably want Ascetic, or maybe access to Memcache or MongoDB for the cool kids, or Redis or Markdown, Gravatar, whatever your application needs. There's a huge community on GitHub, and just like Symfony 2, you can go to github.com, FabPot, Silex Wiki, third-party service providers to get a complete list of what's available. The one thing we don't have is a sort of way to manage the bundles. A way to manage the community yet. In Symfony, you can search for bundles very easily and see who's using them on Connect, but not so much with Silex yet. Although I think we could all harass Fabian, and maybe we make it happen. What happens if you want to create your own provider? It's actually really easy. How many of you have used Facebook before? One? Really? Really? Who's lying now? All right. So a lot of the times you need to add Facebook login to your website because somebody needs this functionality. This is really easy with the Facebook SDK, but how do I take the Facebook SDK and make it available to my app? It's quite easy. All we need to do is create a service provider. So you can integrate any third-party library, whether it's Twig, Doctrine, the Facebook SDK, etc., by creating a new service provider and registering the service with the container. So let's go through a quick example. Okay, so in Symfony 2, the dependency injection container is really complex. There's support for loading it in different ways, whether it's YAML or XML or just PHP. There's a compiler that processes the configuration in various steps. There's the actual builder and then the container itself. In Pimple, it's much simpler. You have service providers and then you have the container. That's it. There's nothing really more than that to understand. So what would a Facebook service provider look like? So we have a Facebook class and we need to share it with the application. But that Facebook class requires a couple of arguments. Like I need the app ID and I need your secret. So I need your OAuth ID and your OAuth client secret. So here we just want to create an instance of the Facebook class, pass in our arguments, and then share it with the rest of the app. And the way we do this is we define the app Facebook with app share, and all app share does is expose a service to the container. So in this case, we just return a new instance of Facebook with the app ID and secret specified, and now we can use this in our application really easily. Okay, that's fine if I have a single page app. But what if I want to make this reusable by the community, and I want to create a Facebook service provider? So I can register any class by calling app share, creating an instance of the class, and returning it to the container. But a lot of times I want to make it reusable. So I want to create a Facebook service provider so other people can use it. All we have to do is wrap this in a class called Facebook Service Provider that implements the service provider interface with a register method that takes the application. And then here we have the exact same code inside the register method that creates an app Facebook instance and just calls the app share method and returns a new Facebook class with our arguments. Now when I want to use it in my application, I can simply call app equals new Silex application, app register, my Facebook service provider, and pass in the array of options that it requires, like the app ID and secret. Once I want to use it in one of my controllers I want to have a homepage that automatically logs you in with Facebook, I can call map the /URL. So we have app get. App get goes to this method, and we can simply call the Facebook service and call get user on this, and now it'll automatically log you into Facebook and come back with a token. And all of that in like 20 lines of code. So it's very easy to extend Silex. Whether it's just for your application and one time, or whether it's create a service provider that you can reuse and contribute to the community, it's extremely easy. Okay, a lot of times I think it makes sense to get started with, there's a lot of boilerplate projects out there now. How many of you use Twitter Bootstrap? How about HTML5 boilerplate? All right, good people. So even better than the Silex skeleton is the Silex Kitchen Edition, because it does a couple of things. It uses HTML5 boilerplate for the layout, so it solves that problem right away. It integrates Twitter Bootstrap for CSS and JavaScript and just the basic functionality that Bootstrap provides, as well as layouts. And then it adds support for translations, support for doctrine, and support for aesthetic. So even if you have a simple application, I recommend using the Kitchen Edition just because it makes it extremely easy to create an entire app, and you have all the boilerplate code done. Boilerplate code being setting up translations in the dictionary, setting up the aesthetic for boilerplate and for Bootstrap, as well as setting up a default structure for your controllers and for your views. So what does that look like? Let's take a quick look. By the way, thank you, GitHub community, because all of these examples I'm showing you, I borrowed from the documentation and GitHub. So you can find all of this on GitHub. So this is a really simple view. Obviously, you have security component built in. I don't think I remember the password, so we'll skip that part. And you have the Twitter Bootstrap and HTML5 boilerplate built into the layout by default. So if we take a look at this, you have HTML5 boilerplate. You also have aesthetic. So you have optimized CSS and JavaScript automatically. And then you have some examples built in, like an example form with all of the Bootstrap form elements, which is quite convenient. So you don't have to spend any time to get started. And then you have an example of how to use the HTTP cache system. So if you really want a good place to start, just to sort of consume Silex for the first time, I recommend taking a look at this example project. It's quite well put together. Okay, so let's take a look at this in code. So here, we'll start with configuration, because I think pretty much all applications start with one or two environments. By default, we just have a dev environment and a production environment. To create a dev environment in Silex, all you really need to do is set app debug equal true. So here's the default structure for the project. I'm not sure if you can see this easily. But we have a vendor directory, a source directory, some tests, and then we have our web directory. So it provides some structure. We have a place to put our controllers. We have a place to put CSS and JavaScript and our assets. We have a place to put any translation files, as well as we have a place for some SQL. So again, this doesn't use Doctrine ORM. It just uses the Doctrine deval with a SQLite database, but you can already see how easy it is to get started. So when we started with the Hello World example and the Silex skeleton, it was started as a single-page app. But we can start to evolve it by creating controllers and mapping the controllers to our routes here. So if we take a look in the source directory, you have source app, which simply registers our service. So if this is a single-page application, this is what would be important. But in this case, we have several service providers. So we have the form service provider, the cache provider, monologue, sessions, et cetera, et cetera. And we're going to simply register them. So first, we use the classes, autoload. We register the service providers. We set up some default configuration, like what is the default locale for the application. In this case, we want to use ascetic. So we're going to register the ascetic extension with Twig and with the container itself and set some options. So you want to use YUI for YUI compressor for CSS and JavaScript compression. And then we want to optimize our assets. So we want to take all of our assets and put them in a single file. And then we just want to return the app context. So this abstracts a bit of the functionality. With Silex, again, you start with nothing. So I have to add all of these services, which is why this configuration is done for you. In Symfony 2, I can simply edit a YAML file or an XML file, change a couple options, and all of this is done for me. This is really the big difference. Again, let's go back to the controller. Let's take a look at the login page. No, let's go right to the form. So here we have this form example. And all it creates is it maps the URL /form and creates a simple Symfony 2 form with a bunch of different options. If we look at what this means in code, is actually really straightforward. We want to match the /form URL. So you can use match, which will handle get and post, or I can use just the get method, which will restrict it to a get method, or the post method, or the put method, or the delete method, etc. In this case, we're just going to match /form because I want to handle get versus post as part of my form. And we'll create a form builder and add some elements to the form, add some constraints. So in this case, we're going to create a very complex form. But really all you need to focus on is we have a simple text field that registers a constraint like assert not blank that makes things required. And then we have some logic to process the form. If the request method is a post, then we want to bind the request to the form. If the form is valid, we want to do something with the data. Otherwise, we want to show the form again with error messages. And if we take a look at what this means, this is the only part that's important. Just like Symfony 2, you have the same form block everywhere in your code. And here we're just going to return app twig, render this form, and pass in the form create view. It's identical to Symfony 2. Instead of the render, calling this render in a Symfony 2 controller, you're talking to the app twig service and calling render on that. The other thing you can do is functional test. So functional tests take a bit more bootstrap, but just PHP unit is a standard for testing, unit testing in PHP. And we provide a web test case in Symfony 2 that allows you to use a fake browser using the browser kit components to crawl your website and then do assertions on the response object. So you can do the same thing in Silex. So here, the first thing we need to do is actually create the application. So Silex includes a web test case specifically for Silex applications. But really the only part that's worthwhile noting here is you register the Silex application, include any configuration in your controllers, and then you can start testing the 404. So here we just want to create a client. We set an expected exception. So I expect to get a not found HTTP exception, which is the class that I did not know yesterday during Celebrity Jeopardy. But I do now, HTTP kernel for everyone that's interested. And we just want to check the request. So we're going to make a fake request with client. We're going to request using the get method, URL that doesn't exist, and we just expect this exception. You can do more advanced tests like testing login and testing authentication in your service. But it works just like Symfony 2's functional test suite. Okay, a more elaborate example. How many of you have used Backbone before? When you use single-page apps, Backbone's really convenient to just glue your views together in JavaScript, and you could just have it be powered by a JSON API. So there's a nice to-do list example. We could dive into that. It uses Twig.js, it uses Backbone, it uses Twitter Bootstrap, and uses Silex for the JSON service. So here we have the simple traditional Bootstrap view, to-do manager. we have a simple list that's glued together with Backbone. I can click on an item and mark it as finished. Notice it's instantaneous. Everything's being done in JavaScript. If I want to delete an item, I can delete an item, etc. And if I want to add an item, I can simply go to New Item, and it shows up in the list. Really straightforward, really simple. I think to-do list is the new hello world for the new generation of programmers. But let's take a look at what this means in code. So again, when we take a look at this app, it's not just a single-page app. It's a bit more complex. The controllers live in one place. We have a set of views, etc. So here, if we start with the front controller, all we're doing is including the source directory app, including the production configuration, and calling app run, which just tells the browser to map the URL to the appropriate controller. Now, if we go to our app and take a look, we're registering some providers again. We start with the Silex application. We register some providers like the Doctrine provider for actual persistence, Twig.js provider, the Twig service for some views, and Ascetic to optimize the CSS and JavaScript. We also add a bit more structure in this application. So we've created a base class for our controllers. So we're going to include a base class for our API requests. So here's what it looks like right now. Our controller class is very simple. It takes the application into the constructor. It calls initialize, where we can add some simple functionality, like register or else. And then if we want to encapsulate our functionality in a class, we can map routes now to methods in the class. So here we have a simple controller class that just takes the app, and the initialize method, we just route /API/to-do to the list to-do method, etc. for each get, post, put, and delete. And then if we take a look at our list to-dos, it's really straightforward. I want to go to the database. I call appdb query, select everything from to-do, order by whether it's finished or not. I fetch all of them from PDO. Again, the appdb service is just the PDO object. And then we just return JSON encode to-dos. This is all you need to do for a complete JSON API. The same for get method. I call this get to-do. Returns a JSON object for this particular ID called JSON encode, and I'm set. If I want to do a put, we call add, and I create a to-do object from a JSON. So I just simply get the request content that you posted to this API, and then I call to-do create, and I just pass in that data. And then I do a database insert. So appdb insert into to-do, and then the array from the to-do. Then I can return a JSON encode again, and the same for update, and the same for delete. Okay. If you want to add a little bit of simple structure, you can create your own model. One of the nice things is just implement JSON serializable, so you can just pass your model class directly into JSON encode, and automatically you can serialize the component without actually using Symfony's complete serializer component. And then you could create some getters and setters to make things convenient in a from array to array. The structure isn't required, though, right? It's you define. What creates a full stack is you defining what the structure is and what the conventions are. And I think Silex, you start with nothing, and then you build these conventions in the structure. And with Symfony 2, here's the structure. Here's where you put your controllers. You create this bundle. All these decisions are already made for you. So I think this works well, especially when you work with a very large team. Symfony 2 is going to be a better choice for complex apps every time, because the decisions are made for you. You just need to read the book to figure out the right way to do things. With Silex, it's whatever the team decides, whether it's a very simple app where I want to just create a couple of methods that map routes to these methods, or I want to do something more elaborate, like have a controller class and have each one of these URLs go to a specific method in the class. You define the structure. I think all that's pretty clear. Okay, so when Silex makes sense, simple applications, RESTful API applications. Silex can replace Symfony 2 in a lot of cases. Again, you can use all the Symfony 2 components in Silex, so it just depends on your application's requirements. Who uses Silex? A bunch of different companies. Sensio Labs, KNP Labs, LIP, White October, BBC. It's tested. It works. There's a full functional test suite. Just like everything Fabian writes, there's a million tests, which is great, so you know it works. When should you use an actual full-stack framework or evolve Symfony 2 into a full-stack framework? When you have a large application that requires real structure or requires predefined conventions, like with Symfony 2. And I think a lot of this is like if you need an ORM or you need a more powerful service container. The Pimple service container is very simple. All it does is expose classes to a container, rather exposes services to a container. And I think if you really need more complex functionality, it's time to reevaluate. There's a great community of supports. Obviously, there's the Google Groups mailing list. If you have any questions, there's an IRC channel in Silex PHP on irc.freenode. And GitHub, if you have a problem, create an issue, eventually it will get resolved or fixed. And if you have questions, you can always go to silex.sensiolabs.org. There's really good documentation as well on the website. So just like Symfony 2, the documentation is amazing thanks to the awesome community. Seriously, thank all of you. Appreciate it. We also have a set of cookbooks and a list of third-party providers to see what extensions are available. So if you need common things like Mongo or Aesthetic, it's pretty much always done for you. Just need to go find the code. If you want to contribute, obviously GitHub's the best place. And there's a guide to contributing. If you want to download these slides, they're on SpeakerDeck already. So just go to speakerdeck.com, blah, 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 URL on the slides. Okay. Well, thank you very much for your time. I hope it was worthwhile. Thanks to Fabian and Hugo and Igor. Get in touch. I'm also recruiting. I know a ton of great teams that are hiring. If you are currently looking for your next gig, you're in New York, San Francisco, or capable of working remotely, I know half a dozen teams looking around, so please feel free to get in touch. Thanks for your time, and enjoy the rest of SymfonyLive.